How's everyone doing? Good, good. So we might be talking about microservices, but this is definitely a macro crowd, so this is going to be great. Let's see here. So I'm Yunong. Thanks for that introduction. And I work at Netflix, right? Has anyone heard of us? Everyone looks confused. No, I'm just kidding. So a quick recap. We're in 100 million. We have 100 million customers. We just recently crossed that milestone. Had a huge party. We're in over 190 countries and streaming some crazy amounts of hours every single day. So it's been fun and exciting. But back to the talk, right? So what is a platform as a service anyway? But essentially, if we boil it down to its basics, it allows engineers and developers to build and manage applications without having to worry about infrastructure or the platform. And so you might ask, but wait, you guys are Netflix. You've been running microservices for years. You've hired this great group of killer service engineers who already know what they're doing. Why are you building a PaaS, right? Why is this relevant? Well, let's take a look at our use case for this specific case. One of the things we're known for is that you can watch the service on any modern device, basically, right? Everything that you guys are holding right now, you can watch Netflix. And the reason for that is we've hired this great group of client engineers who can really, at home building responsive and cinematic UIs. But because we have such a large variety of devices, and this is really our most intimate experience and connection with our customers, and the data for these devices vary per device, we've had to build a way for them to access their data. And so today, we have something called the Netflix Edge API, right? And client engineers now can write very tailored, bespoke data access scripts that they upload to a server somewhere. And so you can see, all the scripts that they can write. And the advantage of this is that, it lets us integrate. It's a point of integration, right? So the client engineers can go ahead and write services that they don't have to maintain, and they can integrate against all the backend services that exist out there that provides data. And so it gives us flexibility, velocity. There's no infrastructure for them to manage. And so it's a really great way for us to quickly innovate on the client side for our customers. And so when we first rolled out this Netflix Edge API, there were about 100 endpoints running live on a single process. This is a few years ago. And fast forward to today, there's now thousands of them out live in prod. And so as we sort of all understand, if you have 1,000 things running concurrently live in production, there are a lot of dangers with that, right? Because there's no service isolation, where we're kind of running into the vertical scaling limits there a little bit as well. We've had quite a few, some outages in the past because one errant script has taken down the entire service. And so let's focus on this layer, and how do we sort of make this more robust? Well, our sort of next generation architecture has meant that, hey, let's break out all of those endpoint scripts into their own individual microservices, right? And so if you kind of look at the architecture there a little bit, mostly JavaScript on the clients. And because now we have the client engineers who are going to be owning their own services, these new microservices, we think we're going to run on Node, because then you get server-side JavaScript, and you have JavaScript in both places, which is handy. And we'll continue to maintain sort of the majority of the code base in Java, because we've made millions of dollars in investments there. But we have this ethos here at Netflix, which is that you should operate what you own. And since the client teams now essentially have to own their own microservices-based microservices that they have to own and operate, it brings a new set of challenges, right? And it comes back to knowing your customer. Who are our customers, right? They're client engineers, really great at building robust, really great at building responsive cinematic UIs, right? But probably they don't have the sort of experience or expertise in distributed systems or operability or scaling out systems and things like that. And so how do we make sure that we're sort of building something, an architecture and a platform that really suits the customer? And additionally, we have to remember our goals, which is really around velocity and reliability, right? We want velocity because that helps us really rapidly innovate for our clients. We also want reliability. If the service is unavailable, it doesn't matter how fast you innovate. Customers can't enjoy our quality streaming service. And traditionally, this means having to make trade-offs, right? You can either go really fast or be pretty reliable. Every time you make a change, there's some risk that your service is gonna blow up. So today we're gonna talk about our paths to achieving both of those goals. And it's really down to three things. One, standardizing your components. Two, having a pre-assembled platform. And three, having an automation and tooling built on top that helps us really get to velocity and reliability. So let's start with the first section, which is standardized components. Most of us here are pretty senior architects or really senior engineers, so I don't need to tell you what's inside a microservice. We already know there's a common set of components that go inside a microservice that helps to make it robust and reliable and efficient. And many of you are probably familiar with all of these components, right? You've used them before. And at Netflix, we've got years of experience building and operating services. So luckily, we have a really great set of open source tooling that we've already open sourced that helps us build microservices out of our standardized components. But why standardize on these components, right? Well, here's a good example. This is a news article that I dug up. And it says, SciTech confusion leads to Mars failure, right? So there's a Mars probe, they sent it to Mars, and it never made it. And if you zoom in, the caption's hilarious. The Mars climate orbiter, now in pieces on the planet's surface. And it turns out it was, they lost the orbiter because one team had used imperial units and the other team had used metric. And the lander promptly flew right into the face of Mars, right? So if we take this anecdote and move it to sort of microservices-based architectures, if you just pick one component out of that whole bag of components that you use to make up your microservices and take RPC, we know there's like a whole ton of RPC options out there. We're actually sort of rather blessed in this day and age we're spoiled for choice. And in fact, I'm sure many of us spend, many hours during our lunchtime bike shedding about which one we prefer to use, right? But so if we left engineers to their own devices and said, hey, when you build microservices, pick whatever RPC architecture you want, you might end up with something like this, right? Because when you have a microservices architecture, you don't just have one service, you have a whole bunch of them. And so that's fine, everyone's picking their own favorite RPC mechanism. Why is this an issue, right? Well, what happens when somewhere along the stack, some of these services fail? What happens when we have failures on Netflix? We get a bunch of mean tweets, right? Customers are not happy. And the biggest things that we're trying to achieve here is, really getting faster mean time to detection and mean time to repair, right? You're going to have failures. Everyone's going to have failures. That's inevitable. But how do we make this faster? And you as an engineer, trying to work the issue, you're trying to get there faster, right? So imagine that now you have n flavors of RPC, right? All on the stack. And you probably have a site reliability engineering team that's sort of, the crack folks that come online whenever there's issues with the service. So how do we expect them to operate and quickly drive to root cause when when we're using multiple different flavors of RPC across the entire stack, right? They can't standardize on tooling. They probably have to understand how each and every single RPC mechanism works. There's no shared knowledge, and so it makes it a lot harder to debug and find to root cause problems with your stack. Whereas if you use one standard RPC, now you can invest in one standard set of tooling, right? Folks will be all completely familiar with that. And so that really helps you, go back to like improving your mean time to recovery and mean time to detection. So the benefits of standardizing, right? All these components. Biggest things are consistency. If you have a consistent set of components across the stack that you can use for all your services, again, it makes it a lot easier to troubleshoot, right? It makes it a lot easier to support. Again, driving back to the whole story around shortening the time to recovery and the time to discovery. Things like leverage, right? Because you've standardized on a common set of components, not everyone has to go and reinvent the wheel, and they can spend a lot more of their time sort of working on their business logic, and you can invest in some platform teams that can work on these components by themselves, and now you've increased your leverage across the company. Interoperability, right? This seems like a no-brainer, right? If all these services are using the same standards and the same components, you're able to interoperate a lot easier with each other, and that means, again, whenever there are issues, right, in terms of reliability, we can much more quickly solve them. And then in terms of velocity, because everything works together, I don't have the cognitive overload of having to figure out, well, what does this service speak versus what does that service speak? Quality is important too. That's something that's often sort of left out, is that if you have a set of standardized components, you can make more investments in that one standard component, and so the likelihood of the quality of those components that you own will go up, right? And lastly, support is a big issue too, right? You have a bunch of engineers in the company who are using all of these components, and they're going to run into issues. And so if you standardize on a few of them, your knowledge base is going to be bigger. You can sort of ramp up the support teams and get quicker support. But what about folks who want to be different, right? I'm a snowflake, I want to be different. And that's okay too, I think. The reality is most folks in the company probably who are running services aren't different. But even if they are, if they want to be, as you probably know, we have this culture of freedom and responsibility at Netflix. And so what that means is, you do have the freedom to go off-road, right? you can go off-road and pick a different technology choice for some component in your microservice. And that's OK. Because often forging ahead and using new technologies fuels the innovation, right? And so a good example actually is us using Node and Netflix. We've traditionally been a big Java shop, but over the last couple of years, our website team decided to forge ahead, go off the Paved path, and bring in Node as the runtime for their rendering stack. And that worked incredibly well for the website, and eventually that made it back into the ecosystem. So like, contrary to what most folks think, the freedom is good, right? Because that lets you really innovate and perhaps bring some of these newer technologies back home. But that comes with some caveats, right? Really, I think it comes down to being responsible, right? Don't just pick a technology because it's new, right? Just because it's new and shiny doesn't mean it's the best thing you should use. And don't pick that technology in a vacuum, right? Really talk to everyone, talk to your peers, talk to folks around the company to make sure that it's the right decision for you. Because ultimately, while you might be equipped to support your service, you're leaving this undue burden on everyone else around you too, because you all play in the same ecosystem, right? So, when we introduced Node, it meant that we had to sort of really talk to the reliability teams, the platform teams, and that introduced a lot of burden for them to have to understand how do I support this new technology. So it's sort of flip both sides of the coin and just really think hard about when that makes sense to go off the Paved path. So let's move on to the second section, which is around the preassembled platform, right? I'm trying to create a new service, and we've talked about the fact that now we've got the standard set of components that exist out there, right? And so, what does that mean? Well, if I want to create a new service, what do I have to do to just get out of the blocks, right? Probably a lot of stuff that I have to do, and I'm sure all of us at some point in our career has to have bootstrap a new service from scratch at a company that they're working at. So what are the steps, right? Well, I go ahead and scrape some docs, wikis if I have them, and read up a bunch about how the architecture works and where all the components are. Maybe there's some sample code that I can copy paste into my new app. How do I figure out, and then here's some questions, right? How do I figure out which versions of each of these components to use? How do I initialize them correctly? Am I configuring them correctly? Hopefully I'm not missing any components, right? And as we all know, this takes often days or weeks for an engineer or a team to bootstrap and get up and running, right? And so let's tie this back to sort of product innovation, velocity, and reliability, right? So trying to launch a new feature. I don't know if folks have seen this before, but over the last week or two, we just launched this really exciting feature, which lets kids pick branching narratives in their movies, which is really awesome, especially for a parent like me. But we just spent like 2 weeks trying to bootstrap a new system, so we didn't have velocity, right? And it's not clear whether the service is even reliable, because I don't know we don't have an authoritative source on how to put together a service reliably, and all that stuff is always constantly changing. Oh, and by the way, I haven't written a single line of business logic either, right? So I'm haven't really started. I just burned 2 weeks. And the problem is hey, I've got this disparate set of components. How do I actually make it easier for folks to bootstrap and get up and running? And again, remember our use case, which is got a bunch of client engineers who naturally don't have the expertise to sort of operate and assemble services anyway. So maybe one thing we could do is put all of these components into a pre-assembled platform. And that way, they're already up and running, ready to go, so that you don't have to worry about it as a customer of this platform. And all you have to do is bring some business logic, right? And so by default, if we pre-assemble a platform, right, you're not actually having to write a single line of platform code, right? And all you have to take care of is just the business logic. So let's talk about what you would get out of the box with a pre-assembled platform, right? One of the biggest things that we just talked about earlier is component management, and this is really important because if you get something that manages all the components for you that go into a reliable microservices, you're less likely to be missing things, right? And some of the more important things are logging, metrics, alerts, because again, you want your service to be reliable, right? And I've actually done this in the past. When I first got out of college and I was working at Amazon, I was the engineer that went and spun up the authentication stack for the then new Portland region, the Portland data center for AWS. And so I was following documentation. They're all scattered around, and I thought I did it all, and now we were live in Portland. Everything ran swimmingly for a couple of months, and then suddenly, 2 months on a row, we get a Sev1 page saying all of AWS is down in Portland. And we're like, oh, that's interesting. Why didn't our alerts fire? And it turns out, right, the new guy didn't realize that you were supposed to add alerts because they weren't in the documentation. And so if you're just following this human process, you're going to be missing things. But if you generate everything together into a platform, then you're going to have a fully reliable microservice with all the common patterns that already exist. So speaking of insights, the nice thing about having a platform and a bunch of components that you own and maintain is that you're able to emit a common set of system alerts, systems, and runtime metrics and logs, right? Because generally speaking, even if you have those common those alerts and insight baked into your service, every single service is going to be emitting a different flavor or a different pattern or a different set of these metrics. And again, if we think about reliability, when something goes wrong and there's 100 or 500 microservices that you have to go then and debug as a site reliability engineering team, and every single one of them emits a different set of metrics, that makes it really, really difficult to debug and operate, right? Because service A's service health might be different than service B's in terms of the metrics they're emitting. But because if we provide a platform and we own all of the components, and we own the instantiation and the startup and the initialization of these things, then for every request that comes in, we can emit a standard set of metrics and alerts and logs for everything that we own, right? And this makes it much easier to reduce your mean time to discovery and mean time to root cause, right? Because this means that you have a consistent set of metrics. Again, this is really helpful for sort of really driving up our reliability. So another thing that a pre-assembled platform can help you with is the ability to configure and initialize all your components correctly, right? And so this is like having a pre-flight checklist, for example. You know that when the platform starts, everything starts up in a way that's correct. Everything is configured correctly. Everything is initialized correctly. All the components are online, and we're using them correctly. And this again goes back to reliability, right? Knowing that every time your app starts, you have the full confidence that's going to be at 100%. So how about some other things, right? Well, how about versioning? You have, maybe 20, 25 different components in your microservice, right? Each of them have different versions. And it's really hard to figure out which versions play nicely with which other versions, right? But if you just pick up a single platform, we can do the hard work of figuring all of that out for you, right? So for our customers, whenever they pick an update of the platform, they know, right, that everything's going to be working correctly in concert and there's no compatibility issues. Again, this ties back to velocity, right? Because as a client team who's trying to launch one of these services, the platform itself is a means to an end for them, right? They just want this to work and sort of inject their business logic and be on with their day. So some important questions that came along the way for us while we were building out our stack and our platform. I thought I'd share some of these with you. One of the biggest ones is, what components are in and what's out of the platform, right? There's sort of, we know that we have this base set of platform components that needs to go inside of every single service. But what about for folks with different use cases? I mean, let's imagine like, hey, I have a team that wants to do some sort of service, some rendering of some UI, right? So they want React to go in the platform because they don't want to manage it. A lot of our apps do data access, and they're using our sort of open source technology called Falcor. So do we put that in the platform? Maybe at some point we have teams who want to run this platform on some of those sort of more back-end services, and so do we put caching in there? And these are all really good questions, right? And a good anecdote here is, initially when we're building the platform, of course we were like, well, it's easier for us if we just maintain a base set, and if you need some standard set of data access libraries, the users can go maintain them, right? And that means we're out of the loop. We don't have to do any of the support when they need to upgrade these specific versions, and they can do this out of the loop for us. But if the flip side of that coin is that if you do that, then you're sort of, your customers are losing some of the advantages that they get by using a prepackaged platform, right? The whole point of this, some might say, is for you to keep up to date with all the different versions. And they just care, because they want the velocity, right? And so, it's kind of this trade-off between velocity versus reliability. So one of the sort of approaches that we've come up with is to have different layers and flavors, right? And so we could have a base platform, but then on top of that, we can layer in additional components on a different layer of the platform that maybe provides data access, or the ability for you to render UIs, or for you to run a backend app if you really wanted to, right? And many others. And I think this is, for us, we're still testing this out, but this, for us initially, has been a good approach. I think we're going to give it some more thought, but I think this is one of the solutions that you can come up with for making sure that, hey, I want to make sure that all of my teams who are using this has a specific platform that they can use. One of the other things to remember is like, you have a bunch of components in the platform, right? And some teams may only use some subset of them, right? And so like if I'm doing data access, I'm not going to be rendering, so I don't need those components. Again, having different flavors and layers means that that platform is only baked with the specific components that they need. Speaking of the platform, how do we actually ensure that the platform is correct, right? Because again, now we've become the gatekeepers, and we're distributing out this piece of software to 15, 20 client teams who need to write these microservices. And so a bug in the platform could be pretty traumatic to our service and to our reliability. And I'm sad to say there's no magic bullet. It just comes down to testing, testing, and testing, right? And so, from very early on in the project, one of our goals was to make sure that we have a fully robust CI and CD pipeline setup that tests everything in the platform. So that includes unit tests, integration tests, functional tests. We test in the cloud. We test every time there's a PR that goes in the platform. We test every build. And this really early on gave us a lot more confidence in the fact that in the fact of shipping this software to our customers. One other thing that I should mention in terms of the sort of correctness of the platform is that you should always dog food with your own service that you build on top of this platform. So we did that early on. We have a sample service that we run, that we exercise, that we deploy to prod, that tests all of the different functionalities and features of the platform. But another good idea I think that we've been exploring is the ability to run other people's test suites on a new version of the platform. So you could bring down another team's service that's currently running, and you need to upgrade the platform. So you run all of their tests on the new platform for them to see if there's any compatibility issues, right? And I think one of the other key things is if you discover gaps in your testing, fill those gaps and test and close the gap. Because just because you can't be perfect, it doesn't mean you can't strive for that perfection, right? So again, making sure that we're very diligent about testing the platform to ensure that it's correct. What about all the components that's inside the platform, right? How do we ensure that those things are correct? Again, like I said, from our customer's perspective, the platform is the gatekeeper for those components. And so if there's a problem with a component, they're not going to think, oh, there's a problem with a specific component, like say metrics or RPC or whatever it is. They're just going to think there's a problem with the platform, right? So how do we ensure that all the components inside the platform are correct? Well, first thing you want to do is make sure you lock down all the versions of the components within each version of your platform. And that way there's no variance, right? And so we're using technologies like Docker and shrink wrapping with NPM that really ensures that all the code within a specific platform version is immutable. It never changes. Additionally, your partners may have really good test coverage, but make sure that you're also inside of your platform tests, you're exercising all of those code paths, right? So don't just test whether the metrics API works correctly. Also test the fact that, hey, when I send a metric in the platform, right, with the metrics API, that I'm seeing the metrics in my metrics subsystem. Again, one of the other things that we've done is that whenever a component team does need to update their component inside the platform, we request that they have a PR that they submit against the platform itself. And because we've set up this expansive testing infrastructure, right, whenever there is a PR, all of the full suite of tests run. And so if there are testing gaps or broken tests, then we know right away, and that gives us a way to get visibility into updates, right? Because you don't want updates to break your customers. The next question, right? How locked down do you keep the platform? Do you and it comes down to a set of trade-offs, right? Do you give flexibility to your customers, meaning that, hey, they can do whatever they want in the platform? I think that's like what we all strive to have is like, hey, have a platform that's nice and flexible, right? And so it gives customers the ability to do whatever they want. But on the other side of that coin, there are things like reliability, right, that you need to think about. So if customers start changing the components around or changing the order that they instantiated or changing their configuration, then maybe you're losing some of that reliability that we got earlier by standardizing and putting everything inside a platform. So things to think about. Also consistency, right? If you can turn off specific parts of the platform or add new things, now your set of services are not consistent anymore or as consistent, and that means that when there are issues, it's harder to triage and fix, right? And support as well, because if you have a consistent set of apps, right, and services on the platform, it makes it much easier to support than, I have a customer who's turned off a bunch of things in the platform, and then maybe that's why their services are misbehaving. So we strongly recommend to our customers, hey, you should stay on that paved path, right? Because we think, especially for our use case right now, which is for data access apps that are authored by client teams, there's really no need for them to stray off the paved path. But again, back to our sort of freedom and responsibility culture, it doesn't mean that you don't build these things into the platform, right? Because you may have customers that do want at some point to take advantage of some of these things, so you want to make sure you build them in initially when you're shipping the platform. So things like being able to override your configs, having access to startup and shutdown hooks, giving them access to third-party libraries, swap, disable, or configure the various components in the system, even giving them access to raw component access, right? I'm not saying like you should tell your customers, hey, go do all of these things, but if you make these things available in the platform at the start, then it doesn't lock you out in the future, right, to providing some of this functionality. It's almost like an escape hatch of sorts, right? Because at some point a customer may come along and say, oh, look, I really need to enable this use case, and they need to ship back to the velocity angle, right? You're not gonna wait around for a couple of weeks or a month or 2 months to ship that feature when you can sort of give them that escape hatch so they can start launching their app. And so don't lock yourself in a box. Provide some of these APIs at the start. So last thing, right? What about platform versioning, right? How do we make sure that when customers pick up new versions of the platform that they don't inadvertently break, right? As we all know, one of the biggest dangers to reliability is shipping new code. So one of the things that we really thought hard about is, from the very start, we decided to use semantic versioning for the API of the platform. And this was really important because this allowed us to sort of give our customers the flexibility. So now if they're following full semantic versioning rules, they can lock to a very specific version of the platform with their build. And that means it doesn't matter what they do, every time they build and deploy their application and their service, the platform components are always the same, right? They're locked to a specific version. Or they could float. They could float on a very specific major version, and they know that every time they build and deploy, they're always on the latest latest version of that major version, right? So there's no API incompatibilities, and they're picking up all the upgrades. And they can float on the minor versions, or they can float on patch, or whatever they want, basically. But it allows them an ability to be very selective about which things they're bringing in and which things they're upgrading. And one of the other things that we found really helpful is really to automate the way that you generate change logs for your platform. Because again, you're distributing this out to a wide group of engineers, and so using tools like conventional changelog, which will automatically generate a changelog for all of your builds, means that hey, when your customers want to figure out should I upgrade to the latest version, all of those changelogs is already there for them to use and easily pick up on. So let's move to the third topic, which is automation and tooling, right? Again, just to harken back, our audience is really engineers who've never deployed or operated services before, right? And we're now breaking the monolithic edge API tier into hundreds of microservices. And now you as a client engineer, instead of working with just that one service to deploy your apps on, you may have to work across 4 or 5 different microservices, right? Imagine you're adding a new acquisition feature or something, and that has to span across all the devices, right? So how do we make this easier for them and faster and more reliable? Well, let's first talk about what it takes to ship a feature, right? I've got some JIRAs and some feature sets, and I need to turn that into a feature that my customers can see. So this is pretty simple. Usually there's like 4 steps, right? I do some development, then I'm testing, right? Then I'm deploying it out to the cloud, then I need to operate the service. They're pretty simple stuff. How can we sort of automate and add tooling to all of these steps to make it easier and faster for our customers and to make it more reliable? Let's talk about development, right? Obviously product managers everywhere want this, right? They want it to be really quick and really fast. And so what we decided to do is to create a CLI at Netflix for a common developer experience. And what this means is it's a CLI, it's a tool, basically that's a unified interface that gives you integration to all the other tools in Netflix. So you can do stuff like easily and quickly bootstrap your environment, right? So bring all the dependencies that you need on a developer's machine and make sure that it's common and uniform. So that makes it easy to support, and that gets engineers out of the cognitive load of like, okay, which version of Docker do I need? Which version of Node do I need? Which version of all these other things? It's consistent every single time, right? Integrate with all the tooling and services that we have in Netflix, right? So that makes it easy to plug into like the Docker registry or artifact tree, or get access to the deployment tools and testing and being able to pull down all of my repositories. Again, it comes back down to sort of improving that velocity and the consistency. And lastly, because if we build a tool like this, then we're able to enable things like one-click launching of the application, both locally and in the cloud, again, saving developers time and support. So in terms of local development, we think we have a pretty good story, right? We're using Docker, so now that means that we can go ahead and drop a Docker container with the platform and your service locally on your desktop, all in one go, and we know that that infrastructure is immutable. And that means that we can build in tools, again, with our CLI tool that lets you do live reload inside of that container. So you're just coding on your desktop, and the code just reloads every single time you save, which is really great because now you can attach debuggers and step through your code, get access to all of your logs, hit the servers locally to test it. And this really improves the turnaround time, right, for trying to get features out of production or to debug things. And oh, by the way, because we're using Docker, I can dropping a production container that we think may be failing and easily and quickly debug, right? So again, hitting on velocity and reliability here. So let's move on to testing. So again, when we're testing, right, when we have bugs, do we want them to show up in production at our customers, or do we want them to show up in our automated tests? Well, of course, we want them to show up in our automated tests, right? But here comes sort of this trade-off conversation with having a pre-assembled platform, right? You as a user of the platform, you're not really testing that the platform's behaving correctly. You kind of assume that your platform team maybe had some platform tests that did that. All you're trying to test is whether your business logic works correctly, right? And so, the better job we can do to improve this process, it means the more our customers will test and be confident their tests will work. But as it turns out, if you have this pre-assembled platform, in order for it to even boot up and service requests, right, a bunch of the components need access to services that live out in the cloud. And most of the time, you're not testing in production when you're doing development, so you're testing in probably a flaky pre-production stage anyway. And so you as the customer of this team, if you just want to test your own code, it makes it really difficult. And you don't have consistency, right? One of the biggest pieces of feedback we've gotten when we talk to our customer teams is, I never know if my tests are running reliably, and when they fail, if it's because of my code or something in the platform, because I'm, across different runs, I get different results because maybe, discovery is down in testing or some other service is down in testing. So, what the solution that we decided to come up with is, provide first-class mocks, right? So really, for every single one of those components that lives inside of your platform, mock them. Provide mocks so that they don't have to go and talk to some subsystem or a service out there in the cloud. And so part of the question of improving reliability is catching bugs before we go there, right? So if we can mock out all the components, that means our users can have better confidence to be able to write these automated tests that run reliably every time because we're removing some of the flakiness of testing out of the platform, right? But it's not just about mocks as well, right? It's about being able to generate mock data. And again, if I'm providing a platform for client teams to write data access apps, right? They need to be able to provide mock data. And so giving them access to an API with these mocks for them to plug in their own data really helps because now they're able to test new changes to their code and see how that reacts to the data that they're going to get back from the backend. Again, all without having to actually make a real request to a server somewhere. So in terms of mock ownership, right? Who should own the mocks? The platform team, right, or the service or the component teams that build all of these services? Well, that depends, and again, it's kind of part of the trade-off conversation. If the platform team own all of these mocks, that would be fine, right? But given the 10s or 20 components that's out there in the platform, probably doesn't scale very well. So ideally, we like the component teams to own these mocks, right? But that makes it difficult because how do they actually integrate these mocks into the platform? Well, one thing that's worked well for us is to actually come up with a platform testing API as a first-class citizen in the platform. So that means that just like you have a runtime API, right? You need a testing API. That means provide a mocking interface for all the components. And now you get yourself out of the loop for providing mocks, and all of your component teams just have to integrate against this very standard set of APIs that lets them provide mocks for your customers into the platform. And so, the goal for testing obviously is to have really great test coverage and to be able to sort of make sure that you're catching bugs before you go to prod. And so having all of those things that we just talked about, including having mocks, being able to run tests reliably, really helps to get us there. Right, increasing that reliability and the velocity. So what about deployment, right? As one of my former boss used to say at Joint, production is war, and it's true, right? You're going off to war, and we have some pretty different experiences in terms of sort of the developer experiences at Netflix, right? We've got this wizened group of sort of killer engineers out there who's been operating services for years, and they have the years of experience to understand and know what it's like to operate a service in production, right? And then we have client engineers, some of them probably who have just graduated boot camp, some of them who's never been to boot camp, And are we really saying we're going to drop them into the middle of war and see how they do? That's probably not the best thing to do, right? I mean, read a statistic somewhere that you're way more likely to die on your first tour of duty in combat than like on your third or fourth. And that makes sense. So how do we avoid, these giant foot guns for our client engineers, right? In terms of deployment and managing their services. Well, let's put them on Rails, right? Let's help them out. We have a lot of really great tooling at Netflix for you to help you manage and deploy your applications and services. But if you don't know that they exist, or you don't know how to use them, and you don't know how to find them, chances are you're not going to take advantage of them, right? Again, this comes back to, we can pre-configure things like pipelines for deployments and rollback so that we know that whenever you do deploy and roll back, these pipelines are pre-generated, they work in the way that we expect, and they're complete, and they're reliable. Things like the ability to use a single command to deploy to any stack. Again, I'm not following through a run book. I don't have the experience. I can just click a button, and that'll just work for me reliably. Things like integration for automated canary analysis, right? You just build that in. Folks might not even know that you need to canary changes sometimes if they're not coming from the same world as you. So building that into your tooling really helps to have a more reliable service. And things like most maybe engineers who are not familiar might not think about things like pre-configured auto-scaling, so to ensure that their service scales reliably as they would expect. So let's talk about operations, right? Again, we talked about, hey, look, I have all of these really great tools in Netflix to operate these services, right? Things like looking at my dashboards, things like looking at all the different events that's occurred to my service. But again, I have these engineers who've never operated services before, right? And so how do we give them that ability to operate a service? Well, how about generating a consolidated view for them? So this is kind of their one-stop shop. It's their dashboard, and it's their integration for all the other tools that exist in Netflix to operate a service. And so building a tool like this means that you can easily see the status of all your services without having to check and manage all the disparate tools. Look at all your deployed versions. Look at my logs. Look at my metrics, right? And this really, really helps because, again, I don't have to learn about where all these tools are, how they work. They're now in this consolidated view for me. And of course, because we own the platform right, from step 2, we can generate dashboards and alerts for them now too, because we know that the platform outputs a consistent set of them, right? So now my dashboards will have things like RPS and CPU and memory and latency all built in. They're all consistent across all of these apps, and they give our engineers, the service owners, as well as the site reliability engineering team, a quick way to see the health of their service. Right? Don't forget alerts. We're going to pre-generate a bunch of alerts for our customers as well, again, so that they get all of this out of the box without having to really figure out which alerts are important. They just know if I get alerted, here are all the things that's wrong with my service, and I know that my service is misbehaving. Again, having a platform really helps because now I can build in automatic analytic tools to help me debug and debug the bugs in my system and debug the performance issues, right? So building sort of tools that lets me one-click generate CPU profiling tools like flame graphs or getting access to core dump analysis. All these things are really helpful, and we can build these in, and we have built these in as first-class citizens in our platform. So today we talked about our PaaS, path to velocity and reliability. And if you take nothing else away from this talk, what you should take away is that it's a set of building blocks, right? So we can start with standardized components. Then by having standardized components, we can move to a pre-assembled platform. And by having a pre-assembled platform, we can move to automation and tooling. But this doesn't mean that everyone should just blindly go out there and start adopting everything that we've done, right? Because having a PaaS is very use case specific. In fact, a lot of our teams on Netflix don't use the PaaS. Some of them are actually moving away from that architecture. Again, it really sort of fits in your use case. But if you do nothing else but just standardize your components, you're going to get a lot of wins around consistency and reliability and get a ton of leverage, right? And if you feel like your use case can work for this, then you pre-assembling them into a platform means that you can automatically generate metrics and increase your velocity and reliability by folks just having to insert their business logic. And again, but then going a step further after you've done steps 1 and 2 and adding automation and tooling, we'll make sure that we can deploy and operate services reliably. So I hope you took some useful learnings from this talk. Thank you very much.